the next type of function we're going to be looking at is called the logistic growth function. As you can see, it has the form shown to the right here, and the function over the variable t, if x was our time variable, would be essentially c over 1 plus a constant a times e to the negative constant b times our independent variable x or t. Um, t can be any real number that we put in for x. So let's go ahead and look at this on the calculator. So this data here shows us the purchasing habits of consumers based on how many ads are shown for a certain product. So let's go ahead and enter this data like we normally would in our stat edit mode. We'll clear out our old lists. And then we have 0, 15, 30, 45, 60, 75, and 90. And on the right, we'll have 1.5, 3.2, 4.5, 15.6, 28, 37.8, and 49. So let's go ahead and go to our stat and then calc, and let's see if we can find logistic, which on my calculator is letter B. And then we'll go ahead and do L1. L1 comma L2, and we'll put it in our Y, because this one will be a really complicated one. You have to type all out. So Y variables, function Y1, and let's go ahead and hit enter. It takes a little while for the logistic function to work. So there we have it. We have Y equals C over 1 plus A e to the negative bx, and C is 55.9, so we have Y equals 55.9 over 1 plus an A was 50.2 e to the negative bt, so negative, or I'm sorry, negative bx. So negative 0.06 times x. So that's our logistic function. Let's go ahead and look and see how that looks on our graph. So I'm going to go to zoom stat. You can see it fits it pretty well. It comes out to that kind of S shape that we saw earlier. Now notice the question's actually asking us to predict the limit of growth here, the limit to the percentage of people that will use our buy our products, and we know that makes sense because no matter what product it is, not 100% of the consumers are ever going to probably buy that. So you kind of do reach this limit as you're going along. So let's zoom out once just in case we're not quite at the limit, and um, let it go in its function there. And as you can see, it does kind of level off clearly over to the right here. That limit appears. Let me actually turn my stat plot off so I can trace the model. So I'm going to go to second stat plot and turn that off. and just go back to the graph. So now when I trace it, it won't be on my stat points. It'll be on the actual function here. Um, so it looks like we get up to about 54, 55, maybe even 56. I'd say 55.9% seems to be our limit here. So 55.9%. So now go ahead and see if you can generate your own logistic growth graph based on this function here and figure out the limit of the probability of friends who say they would like to solve.